ax squared plus bx plus c equals 0. If we have any quadratic and we want to find the values of x, which we can input it such that it will give us 0, well, we all know we can apply the quadratic formula, that is minus b plus or minus b square plus or minus square root of b square minus 4ac over 2a, right? But the problem with the quadratic formula is that in trying to sort of condense it into one formula, we have made it harder for anyone to sort of make sense of it. In fact, I made a video on why quadratic formula works, because I feel like it is the formula that everybody knows, but few people know why it actually works, because it's hard to tell just by looking at it. There's a square root there. How did the 4ac come over there, and so on. Before we move on to the alternative to the quadratic formula, let us briefly see why this is relevant to us. So, if we have any quadratic, why do we care about the zeros of the quadratic? Well, we care because it's actually the solution to an equality. So, if I want to find ax squared plus bx plus c, if I want to find when this quadratic is some number, let's say 17, I can basically just rearrange so that this is c minus 17. I have a new quadratic and I can find the 0 of this new quadratic, and that would be the solution, right? So there's this person, Professor Shen Loh. He's a math professor at Carnegie Mellon University, and he also teaches the US IMO team, I think. And he came up with a different way of solving the quadratic formula. I'm not sure if he came up with it or if he rediscovered it or whatever the case is, but there's a different way of solving the solving for the zeros of a quadratic equation. And the reason why it is a much better way is because when you are actually going through the process, you know what you are doing. Like it makes sense when you're doing it. So if you have any quadratic ax squared plus bx plus c, the very first thing you do is that you basically want the quadratic to have the coefficient of x squared as just simply 1. So you just divide everything by a. And there's a reason why having 1 as the coefficient of x squared is important to us. So if we take any quadratic, let's say x minus 5 and x minus 7, if you want to find when this is 0, well, if we want this to be 0, then it will be either when this is 0 or this is 0, because 0 multiplied by anything is 0. This is 0 when x is equal to 5, this is 0 when x is equal to 7, so these are your roots. Now, the thing is that I can multiply this whole thing by any number and it still won't change the answer. So if I multiply both sides by, let's say, 8, the roots of the equation are still the same. Actually, what the effect of multiplying that 8 would be, that if previously your quadratic looked like this, right, now after multiplying it by 8, it would be much steeper, because everything is now exaggerated by a factor of 8. Right, so let's go ahead and just expand it out. I will keep the 8 out here. Actually, let me use yellow color. I will keep the 8 out here so you can track where the 8 comes into play. So the way you multiply these two brackets is that you take one term, multiply it with this, then with this, and then you take the other term, multiply it with this, and then with this. And so we get x squared, and then we have this x multiplying with the root over there, which would be minus 7x, and then the same goes for the other bracket, it would be minus 5x, and then the two roots multiply together, which will basically be 35 equals to 0. Right, so if Okay, so this would basically be equal to x squared minus 12x plus 35. Now, if I multiply, if my quadratic was not in the form that it has a 1 over here, if it's instead something like this, minus 80 plus 96x plus 280 equals to 0. Right. So when we look over here, right, when we have any quadratic in the form x squared minus bx plus c, we can notice that the way we got the b was that the way we got the minus b was that we added up the two roots. So we added up the two roots and we got the negative of the coefficient of x, right? And as far as c goes, well, we got c when the two of the roots multiplied together, that is 7 and 5. Right, and all of this happened when the coefficient of x squared was 1, simply because when you multiply x by x, it will give you x squared. Right, so that's why a quadratic in this form is a quadratic that we can use better. So let's kick this 8 out, let's send it to the other side, and we are left with this x squared minus 12x plus 35 equals 0. Right, so once we have our quadratic in this form, one thing to notice is that since minus b is the root, let's say the roots are a and b, then minus b is basically the sum of the two roots, and plus c would be the product of the two roots. Right, so we have in a quadratic we have two roots, and if we have two roots, then we can basically any two number a and b can basically be written as a plus b over 2, which would be the average plus some distance, and a plus b over 2 minus some distance. Right, so if you have any quadratic like this and this is the average of the two roots, then one of the roots will be minus some value and then plus some value, right? So the average we can see would be a plus b over 2, which is minus b over 2. So we can see that a and b will be minus b over 2 plus some d and minus b over 2 minus some d. Right, so we can notice that we know what the product of the two roots are. We know that it is plus c. So, and we have also figured out how we can represent the 2 in terms of b. And so what we can do is we can say that minus b over 2 plus a d multiplied with minus b over 2 minus a d. In other words, we are multiplying both of the roots, it will give us c, right? And so we can expand this out. It would be b squared over 4 minus d squared equals c. And now here we are interested in finding out the distance d, which we can find out now because we have the c and we have the b squared over 4. So enough working with the b's and c's. Let's look at our equation here. X squared minus 12x plus 35 equals 0. Right, so minus b is basically 12, and so we can say that the roots will be 12 over 2 minus some d and 12 over 2 plus some d. Right, and we can see that c is 35, and so we say that 35 is equal to 6 minus d and 6 plus d, which we can see that would be 36 minus d squared. So we are interested in finding out what d is, and so if we rearrange this, d would turn out to be square root of 1, which is just 1. Right, so here we are done because we have the d, and we can now say that 6 minus a 1 and 6 plus a 1 are the two roots, that is 4 and 5, sorry, 4 5 and 7, and we are done. Right, even if you say that this was d squared equals 1, so d can be either +1 or -1, but since we have the two root sets as 6 minus 1 and 6 minus d and 6 plus d, it doesn't really matter whether you take the plus sign or the minus sign, right? We can see that they have alternating, basically one of them is minus and one of them is plus, so it wouldn't matter, right? And that's the whole alternate method. Now this method is much better because throughout the process you can see what you're doing. You can see that we took the average and then we expressed it in this form as products, and then we rearranged to get the deviation or the distance. And once we got the distance, we knew the average, so one of the roots would be average minus the distance and the other would be average plus a distance, and that's your method.